Okay, so this problem is asking us to find all values of p so that y equals x to the power of p is a solution to the differential equation 3x dy dx equals y. Okay, so notice that we have y equals x to the p, and this means, of course, that dy dx equals px to the power of p minus 1 by the power rule for derivatives. Thus, if we want to find the values that are a solution to this differential equation, we would need to take, let's see, 3 times x times dy dx, which is px to the p minus 1, has to be equal to y, where y is x to the power of p. So therefore, let's see if we try to collect like terms here and simplify. Let's say I have x times x to the p minus 1, so this becomes 3p x to the p equals x to the p. And so if we need 3p x to the p to be equal to 1x to the p, this implies that 3p is equal to 1, and thus p must be equal to 1/3. So the solution to this problem is p equals 1/3. Next, find all values of capital B so that y equals radical bx plus 3 is the solution to this differential equation. So let me rewrite this as y equals bx plus 3 to the power of 1/2 so that it's easier for me to do a derivative and get dy dx by the power rule would be 1/2 bx plus 3 to the power of negative 1/2, and then of course by the chain rule we'd have to put a b in there as well. So this provides the dy dx as b over 2 bx plus 3 to the negative 1/2 power. And so when we bring it over to the differential equation dy dx, we would need b over 2 bx plus 3 to the power of negative 1/2 equals 5 over y, and y itself was the radical of bx plus 3. So therefore b over 2 bx plus 3 to the negative 1/2 would have to be equal to 5 bx plus 3 to the negative 1/2. And since those are equal, that would mean b over 2 would equal 5, and hence b equals 10. And that completes that problem. So now for our last one, let's try finding all the values of a that make y equals 7e to the ax a solution to this second derivative differential equation, right? The second derivative, second order differential equation, we would say. So y equals 7e to the x. The first derivative with respect to x would be 7e to the ax multiplied by a by the chain rule. I'm going to place that out in front. And then the second derivative with respect to x would be, let's see again, 7a e to the ax, and then multiplied by another copy of a, so let me just put in a squared. So then when we come over to the differential equation needs d squared y dx squared, the second derivative, 7a squared e to the ax, to be equal to 9 times y. 9 times 7eax. So 7eax, 7eax, and that means we need a squared to be equal to 9, and thus a should be equal to plus or minus 3.